Children, today we are going to study geometric progression. Like AP we have studied, AP is a sequence in which the second term minus first term and third term minus second term, the common difference is same. That means we have to add or subtract any term to obtain in the preceding term to obtain the term, right? So in the geometric sequence, here we are multiplying or dividing any term in the preceding term to obtain a term, right? We have to multiply or divide by a fixed quantity in its preceding term to obtain the next term, right? Let's start with an example and try to understand few important things. Like, take a sequence which is written as 2, 4, 6, 8. Now you can see that every term when multiplied by 2 forms the next term. See, 2 is written, when you multiply 2 into 2 you will get 4. In 4 when you multiply 2 you will get 8. In 8 you will multiply 2 you will get 16 and so on. So we are multiplying by a fixed quantity 2 in every term in the preceding term to obtain the term, right? This is what the definition of the GP. Now here this 2 is the first term and we know that the first term is represented by a, small a. So the value of small a, first term is 2. AP we have studied about the common difference T2 minus T1, T3 minus T2. Here we are going to study about the common ratio because we are multiplying or dividing with the term, no? So that term will be, that fixed quantity will be called common ratio. And we can obtain this common ratio by dividing the second term upon first term, any term by its preceding term. T100 upon T99. What the value of common ratio? It is represented by R. So here if you say T2 upon T1 when we do what we'll get 4 upon 2, that will be 2. Right children? So this way we can we can find the value of common ratio by dividing the term by its preceding term. Right children? Let's try to think more upon this sequence given. See, now concentrate on this term 2. This 2 can be written as 2 into 2 to the power 0. The value 2 to the power 0 is 1. 1 into 2 is 2. This 4 can be written as 2 into 2 to the power 1. This 8 can be written as 2 into 2 to the power 2. Now when we observe, we see that the first term is 2 into 2 to the power 0. The second term is 2 into 2 to the power 1. When 1 is there, 0 power is there. When 2 is there, 1 power. When 3 is there, 2 power. That means for a particular term, you will get the power of the common ratio 1 less. That means we can say that for nth term of the sequence, it will be 2 into 2 to the power n minus 1. When n is there, so the power will be 1 less, the power will be n minus 1. So we can say that for finding the nth term of the sequence of the geometric progression, that will be Tn equals to a r to the power n minus 1. So this way we can obtain the formula for finding the nth term of the geometric progression. Right children? Understood? The first term, the common ratio and the nth term of the geometric progression. Right children? Note down please. Let's see few sums based on the topic nth term of the sequence. Right? What is the formula that we have discussed for nth term? Tn equals to ar to the power n minus 1. Let's see in this sum the question says find the ninth term of the sequence. Sequence is 1, 4, 16, 64. So the first term of the sequence we can clearly see it's 1, right? And if we have to calculate the common ratio, so that will be T2 upon T1, T3. We don't know that the common ratio will be same or not because it is not given that the sequence is a geometric sequence, right? So we'll check by dividing few terms. Like here I have done T2 upon T1, T3 upon T2, T4. In every way we are getting 4 result. That means the common ratio is same, which means that the given progression is a geometric progression. Now if we see that the nth term formula of the geometric progression, which is Tn equals to ar to the power n minus 1, when we put n equals to 9, because we have to calculate the ninth term value, so formula will be ar to the power 9 minus 1, that is ar to the power 8. Now when we substitute the value of a and r here, what we'll get? A is 1 and r is 4, 4 to the power 8, and which has value 6, 5, 5, 3, 6. Right. Now see another sum, children. In this sum, the question is find the 10th term of the geometric progression. Now here the geometric progression is given. Now we don't have to check whether the common ratio is same or not, right? We will check the common ratio same when it is not given that the given sequence is a geometric sequence. Remember, children. So here the sequence is 12, 4, 1 wholes 1 by 3. It's a geometric progression given in the question. That means the first term is 12. The common ratio will be second term upon first term, 4 upon 12, that will be 1 by 3. Right, children? Now formula for finding the nth term is Tn equals to AR to the power n minus 1. So we have to calculate the 10th term of the sequence. Now when we put n equals to 10 here in the formula will become T10 equals to AR to the power 10 minus 1, that is 9. Right, children? Now when we substitute the value of A and R here, A is 12 and R is 1 by 3. We have calculated, substituting A is 12 and R is 1 by 3. We'll get 3 into 4. 12 can be written as 3 into 4 into 1 by 3 to the power 9. By applying the law of indices, when we simplify, we'll get the value 4 into 3 to the power 8. Right, children? We'll get the value 4 into 3 to the power 8. Now, the value of 3 to the power 8 is 6561. So, the simplified answer will be 4 upon 6561. Now, when the higher powers are given, you can leave your answer here only. This will be accepted, right? If it is not written that to the simplified form, then you can leave your answer. Note down, children. Let's see another sum, children. In this sum, the question says find the next three terms of the series 2 by 27, 2 by 9 and 2 by 3. Right. So, we don't know whether the sequence is GP or AP. So, what we'll do, we'll check. The first term of the sequence is 2 by 27. The common ratio is T2 upon T1. If it's GP, we can see it's not an AP. So, let's check it's an GP or not. So, T2 upon T1 when we'll do and simplify. This is the second term, this is the first term. It will get reciprocal. 2, 2 cancel, 9 3s are 27. We'll get 3 as the common ratio. Now, if you calculate the common ratio between third and second term, again, on simplifying, we'll get the same common ratio. That means T2 upon T1 equals to T3 upon T2. The required series is a GP. The given series is a geometric progression. Now, if it's a geometric progression, the nth term of the geometric progression formula is Tn equals to AR to the power n minus 1. Right. So, we have to find the next three terms. Next three terms will be fourth term, fifth term and sixth term because three terms are given. So, next three term will be fourth, fifth and sixth term. So, if we calculate the fourth term of the sequence, that will be AR cube, AR to the power 3. The value of A is 2 by 27. The value of R is common ratio is 3. When we substitute and simplify, we'll get value 2. Right. When we calculate the fifth term, so the fifth term formula will be AR to the power 4. A has value 2 by 27. Common ratio is value 3. When we substitute the values and simplify, we'll get value 6. A sixth term will be AR to the power 5. A is 2 by 27. R is 3 to the power 5. When we simplify, we'll get value 18. So, from here we can say that the next three terms of the sequence will be 2, 6 and 18. Right, children? So, this way we can find the nth term of the sequence or any term of the sequence. Right? Note down, children.